Hello everyone, welcome to my channel. So in this lectures, we will continue our introduction of counting technology in probability. So in our previous videos, we already introduced two counting technologies. They are the multiplication rules and permutations. So if you haven't looked at them, so please look at my previous videos first in this channel. So in this lecture, we will talk about the last technology, is combination of the sample space and events. So what is a counting technology we talk about? So they are a way to help us find how many outcomes we can have in a sample space or event without write down all the specific outcomes in this site. So here for the combination, this is actually a little similar of the permutation of subsets. It's also a question about we select some objects from a total number of objects. So we also said here we select R elements in the total N objects. So this is also we have n objects and we want to know how many unordered arrangement of them. So here this is a very important word is unordered arrangement. So this is a key difference of between the combinations and the permutations. Permutation is about ordered arrangement. So that means for these n objects they are different. However, for the combination, this is about unordered arrangement. So here, for this one, in fact, generally we are more interested about if these n objects are same, then this is a trivial question, right? So we just put them in a line, and no matter how we change the order, they are exactly same. So this is not interest. So generally, when we talk about the combination, actually what we mean is combination of subsets. So this is similar of the permutation of subsets. So this means we want to select R objects from the total N objects. So this is we select the R objects from N objects. So here, let me write down this is unordered arrangement. So this is a very important for this combination. Okay, so here similar with the permutation, we will also use a symbol to denote it. So in permutation we use a P. So here, of course, for the combination we will use a C. So this is a C super N and sub R. And in some books they also use a parenthesis. So they also use a parenthesis with N above the R. So they have the similar idea. It just depends on your textbook which one you will use. And then the formula for this one is we use a factorial N factorial divided by R factorial times N minus R factorial. Okay, so in other words, actually this one is very similar for the permutation of P and R divided by R factorial. Okay, because P and R, this one will equal what? So this one is equal N factorial divided by N minus R factorial, right? And then we divide it again by R. So by the rule of the dividend, this will means what we have on the left hand side. Okay, so here how we can understand why the combination of a subset is look like this. So you can think first what we do. We select R objects from the N objects. So the way we can choose this is permutation of subsets. However, when we done this, we will find, okay, we didn't care about the order. So that means now we have the R objects and we can change the order. So the order of R object, this is about the permutation, right? This permutation of R object is R factorial. So we want to remove this order from our total answer. So that's why remove means here we divided by the R factorial. So this is a similar with the answer we talk about the permutation of similar objects. So this combination actually is combined with the permutation and the permutation of the similar objects. Okay, so this is an explain of how we can get this formula for the combination. And now let me give you an example of this. So this is our example. So the example is, assume we have 20 students register one course, and now we need to arrange their exam. So maybe because of the size of the room, so we need to select 12 of them and let them take the exam in classroom 1. So this question is how many arrangement can we have? So if we want to talk about this, so here the first thing is we need to think about what is our N, what is our R, and this is a permutation or this is a combination. So here in the question we can see this is 20 students and we need to select 12 of them. So by this question is very clear. Here our N should equal 20 and R is equal 12. Okay, so actually here is a tip I can tell you to check your answer is correct or not. So about the permutation and combination, we always select a subset of something, right? So that means that the value of N is always larger or not or equal to the R. So here this is a way to check your answer. And then the next thing is this question is about the ordered arrangement or unordered. So this is an important question. So now we need to read this question. So in the question they said we need to find 12 students and let them take the exam in room 1. We didn't say we need to put them in some site, we need to order them, or we need to like anything about this. We just put them into the room 1. So that means here the order is not anything we interested. So that's why in this question, what we want is we want an unordered arrangement. Okay, so now if this question is about an unordered arrangement, in other words, this question is about a combination. Okay, so if later when you meet a problem, no matter in exam or in your real world, you need to find a way to decide is a permutation or combination. Okay, so now we know this is a combination. So the last thing we need to do is we just need to use the calculator to help us find the answer. So for this one, what's the answer? So the answer is use the formula n factorial divided by r factorial and times the n minus r factorial. And when we plug in the answer, so we have this will become 20 factorial divided by 12 factorial times 20 minus 12 factorial, right? So this will be 20 factorial divided by 12 factorial and times 8 factorial. So this is what we have. And then here, before the end of this lecture, what will we know? Like here, if our question is another, we still have 20 students, but now we want to select 8 of them and put them in maybe room 2 or maybe room 3, anything not in room 1, right? So this question will become select 8 students from 20 students and put them in some other room, not room 1. So then in this one, it's still an ordered arrangement, so it's still a combination. However, now when we look at the formula, this will become C20 and sub 8. So if we use the formula, what we will have 20 factorial, or in other words, the n factorial divided by r factorial n minus r factorial, and this will become 20 factorial, and now r is equal 8, right? So if you compare this equation with the green equation, do you find something interesting? So actually for the numerator of this one, this is exactly same. However, if we look at the denominator of this one, we will find the denominator is just change the order. So here we know for the multiplication, no matter 1 times 2 or 2 times 1, the answer is always same. So by this one, actually I can tell you a remark of this one. So this is if we have Cn r, the answer of this will equal Cn sub n minus r. This is always true when we talk about some combination. Okay, so this is a remark I want to tell you, because sometimes if you play with combination, this rule is very useful. So this is the end of this lecture of the combination, and now we are already in the introduction of the counting technologies. In our next lectures, we will start to talk about what is probability. So in our previous video, we just talked about some terminology, the sample space, events, and we talk about some rules about this, so like counting, technology, and the rule of size. So in next lecture, we will start give the definition of probabilities. So hopefully you will watch the next videos, and please subscribe this channel.